This is Professor Urbis White. Today we will start graphing lines on the Cartesian coordinate system. So we need to find out how the Cartesian coordinate system works. Alright, so let's start. Let's start plotting points first. We have 4 quadrants. You have 2 axes. This is your x-axis. And this is your y-axis. This is called the origin. Okay, this is how it works. Quadrants. This portion is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. 1, 2, 3, 4. Now, if we are talking about a point that's like that, we show it with what we call an ordered pair. And this one is the address for the x-coordinate, and this one is the address for the y-coordinate. So this one is x-coordinate, and this one is y-coordinate. The way you put it, the x-coordinate tells you whether or not you're going right and left. The y-coordinate tells you whether or not you're going up and down. If it is positive for the x-coordinate, it's to the right, negative to the left. That's for the x-coordinate. For the y-coordinate, up is positive and down is negative. Okay, so I have A, 0, 3. So I don't go right because I'm at 0. 3 is positive, so it's going to go up. 0, 3. 1, 2, 3. Here is my A point. Now the other thing you need to do is, this one works like a number line, so this is 1, 2, 3. Just put tick marks to a few of them, -1, -2, -3. And this one is 1, 2, 3 that way. And this one is -1, -2, -3 that way. And so forth. So A is up there. Let's look at B. 0, -4. How does that work? 0 against 0, -4, down, 1, 2, 3, 4. Here's my B point. So I did A and B. Let's go and let me move this to the left so you can see. Now I need C, which is 2, 0. 2, 0 means on the x-axis, I go to the right, and 0, no up. So it is 2, 0. Here you go. This is my C point. D point is -2, 0. -2 is 1, 2 to the left. That's my D point. E point is going to be 3, 1. So that's 1, 2, 3, and 1 right here. That I shouldn't have written there. E. And F is -3, 2. 1, 2, 3, and then 1, 2. F. And G is -3 and -3, and that one is going to be -3, 1, 2, 3, and -3, 1, 2, 3. And that one is my G point. So we put a little bit of everything on each quadrant. Let me zoom out so that I can actually fit more stuff in here. All right, here we go. This is a little better. Let's go to the next one. All right. The word collinear and not collinear, how does that work? Collinear means on the same line, and non-collinear means it's not on the same line. So let's look at it. The question is, are 3, 1, 2, 1, and 4, 1 collinear? Okay, let's go put them on. 3, 1 is, this is 1, 2, 3, 1, 2, 3. 3, 1 is to the right, 3, and up 1. 3, 1. Let's do 2, 1. Up to the right, 2, up 1. And 4, 1. And that one is to the right and up 1. And now let's see if those are collinear. It looks like, even with my drawing, they are collinear. Okay? Let's put arrows. That means they go forever to the right and left. These are collinear, yes. Okay, now let's go to the next one. 2, 4, 3, 6, and 4, 8. Where is that one? I'm going to do that with the red. 2, 4, 2, and 4. 1, 2, 3, 4. 3, 6. That one is 3. 1, 2, 3, 4, 5, 6. And 4, 8. 4. 1, 2, 3, 4, 5, 6, 7. One more. All right, so let's look at it. Are they on the same line? Yeah, it looks like it. But to make sure that they're on the same line, you need to make sure that you check this algebraically. Sometimes it may be close enough, but you're not quite sure. So make sure that you check that algebraically later on. And I'll show you how to do that. All right. Now, linear equations. A linear equation is an equation that looks like this. Ax plus by equals c, where a's, b's, and c's are numbers. And x's and y's are variables. Now, first question is, so there is no exponent, there's exponent 1, that's a linear equation. The question is, do ordered pairs satisfy an equation? Remember, this one is called an ordered pair because they're in order. This one is called the x-coordinate. That's the address on the x-axis. And this one is called the y-coordinate. That's the address on the y-axis. We talked about that. Now, if somebody says, does this ordered pair satisfy this equation? What that means is you go and you plug in 1 for x and 1 for y and check if the equation works. Here we go. 2 times 1, instead of this x, I put 1, plus 3 times, instead of that y, I put 1. Is that 5? It looks like it. So you say yes. 1, 1 is satisfying that equation. 2x plus 3y equals 5. How about 2, 1? So let's put 2 for x and 1 for y. This one gives me 2 times 2, 4, plus 3, that's 7. That is not 5, so the answer is no. This ordered pair does not satisfy that equation. All right. Now let's go to the next step. Graphically, what does that mean? So let's look at whether or not something satisfies an equation. All right, 2x plus 4y equals 8. 0, 2, let's put 0, 2 in there and check whether or not that satisfies that equation. 2 times 0 plus 4 times 2, is that 8? It looks like it. So let's put 0, 2 in here. This one is 1, 2, 3. 0, 2 is, x-coordinate is 0, 2 is here. Okay, so let's do another color. 2, 1. 2, 1, let's check that, is 2 times 2 plus 4 times 1, 8. This one is 4 plus 4, that's 8 as well. That also satisfies. Let's see where 2, 1 is. 1, 2, and then 1. Here it is. Let's look at 4, 0. 1, 2, 3, 4, and 0. It's here, and let's check the equation. Is 2 times 4 plus 4 times 0, 8. It looks like it. And guess what? When these 3 points satisfy this equation, and they have something in common, look at that. They are collinear. So, graphically, that's what it means. That means that this red line is actually the picture of this equation, and these points are the points that I used to draw it. Okay, let's go to the next one. Let's talk about x-intercepts. X-intercepts are points on the x-axis, and we are talking about x-intercept oval line. Now, if we are talking about a line, let's draw a line, it doesn't matter what it is. This point is my x-intercept. And let's look at the coordinates of that. If this is 1, 2, 3, the coordinates of that point is simply 3, 0. Let's do another line. Okay? And again, this point is my x-coordinate, x-intercept. And what is that? -1, -2, -3, and that's -4. So that's -4, 0. That's another x-intercept. What do these x-intercepts have in common? Look at this. Their y-coordinates are 0. So to find an x-intercept, if somebody is giving you a point, they go, okay, well, here's the equation, find the x-intercept of that line. All you have to do is just put y-coordinate or y 0 and you'll find your x-intercept. But graphically, this is what it means. Okay, let's talk about the y-intercept. Now let's talk about a line again. Here's a line. Y-intercept is the point where this line cuts the y-axis. Here's the y-intercept. What are its coordinates? 1, 2, 3, 4. So the coordinate 1, 2, 3 is 0, 3. Let's do another one. Doesn't matter what it is. Here you go. Again, here's your y-intercept where it cuts the y-axis. And this one has the coordinates 0, -1. What do they have in common? In this case, look, this is 0 and this is 0. A y-intercept is an ordered pair where x-coordinate is 0. So you have to remember that. For y-intercept, x-coordinate is 0. For x-intercept, y-coordinate is 0. All right. So that actually ends the portion of putting lines and dots on the Cartesian coordinate system on the x and y axis. And we are going to do more advanced stuff in a minute.